Welcome to the Chlorine Institute's presentation on preventing non-accident releases, or NARs, by properly securing sodium hydroxide solution and potassium hydroxide solution tank car shipments. These chemicals are also commonly known as caustic soda and caustic potash. They will collectively be referred to as caustic throughout this video.
During this presentation, you will learn the definition of an NAR, see a review of caustic tank car NAR data, and learn tips for preventing caustic NARs. The tips provided in this video are applicable for both loaded and residue tank car shipments.
What is an NAR? NAR stands for Non-Accident Release. It is a standard metric used by the U.S. Department of Transportation, or DOT, and Transport Canada to measure trends in hazardous materials releases during transportation.
NARs single out releases that occur in transit but are not related to an accident. Per U.S. regulatory requirements, all releases of hazardous materials from transportation functions are required to be reported to the DOT by completing and submitting a DOT Form 5800. Transportation functions include, but are not limited to, the transportation or movement of the product in commerce, as well as on-site loading and transloading operations when a carrier employee is present. See Section 49 of the U.S. Code of Federal Regulations, or 49 CFR, Part 171, for more details on reporting requirements. These reports may be completed by the railroad or trucking company while the package is in transit, or by a plant employee if the incident is on site. The DOT database includes reports for all modes of transportation and all package types, including railcars, trucks, drums, cylinders, totes, etc., and for all phases of transportation, including loaded and residue shipments.
It is important to note that, according to DOT definition, a residue shipment is not considered empty.
According to DOT's definition, residue is the material remaining in the tank car after its contents have been unloaded to the extent practicable with properly functioning equipment. Empty only refers to containers which have been cleaned of their hazardous contents and purged of hazardous vapors, leaving no amount of hazardous product. The Association of American Railroads, or AAR, has certain responsibilities designated by DOT for overseeing the operations and performance of the rail industry, including tank car aspects. Under a task force of its Hazardous Materials Committee, the AAR tracks NAR incident data regularly and develops guidance and resources to aid the industry in reducing these incidents. The data used in AAR's analysis is not to be confused with that which is reported in the DOT database, because AAR only considers incidents that occur while the tank car is in the railroad's possession. For example, the AAR does not consider incidents that occur during on-site loading and unloading at a shipper's or receiver's facility. More details regarding AAR's NAR tracking and guidance may be obtained through their website. Releases that occur during transportation functions are reported differently than releases within plant processes. The primary difference is that for transportation-related releases, there's no reportable quantity threshold, or RQ, as established by the U.S. Environmental Protection Agency, or EPA, which needs to be reached to trigger reporting. All transportation releases, no matter the quantity, require reporting to DOT. Basically, if you can see it, smell it, or hear it during transportation functions, it is an NAR and requires reporting to DOT. NARs can be very expensive. The true cost of an NAR includes a wide variety of expenses, such as medical costs associated with personnel exposures, costs to mitigate the spill, and ongoing costs associated with necessary environmental monitoring after cleanup. Costs are also incurred when resources and equipment have to be redirected, resulting in facility operation disruption and lost utilization of the tank car. Another potential cost for tank car spills are railroad fines. Some railroads fine shippers for NARs due to their own rail service interruption, which may be fixed cost or variable based on the length of the service interruption the railroad incurs. The Federal Railroad Administration, an agency under the DOT that is responsible for rail activity, can assess fines for NARs, which can be costly and sometimes involve lawsuits. Also, as a result of an NAR, your company and the railroad can suffer a damaged public perception, another real cost that is difficult to quantify. The Chlorine Institute, also referred to as CI or the Institute throughout this presentation, uses the DOT 5800 reported NARs to monitor the performance of the industry's efforts in reducing preventable caustic releases.
CI's Transportation Committee sets long-term and incremental goals in an effort to reduce incidents involving bulk packages for all of the chemicals covered under the Institute's mission, including chlorine, caustic, and hydrochloric acid. While the long-term goal is to achieve zero releases in transportation, this committee's current incremental goal is to address at least the top 2 causes for each product and mode by developing programs and practices to prevent future transportation incidents and ultimately achieve zero releases in transportation. This chart shows the total number of caustic tank car incidents reported to DOT from 2011 through 2022. The fluctuation seen in this chart over the years highlights the need for CI, as well as caustic tank car loaders and unloaders, to continue safety improvement efforts to consistently reduce the annual totals trend. This next chart shows you the cumulative tally of incident causes or leak sources over the same 10-year period. The causes, reflected as blue bars, are those considered to be non-accidental releases, and those reflected as gray bars are releases due to derailments or accidents. You'll see that human error involving the bottom outlet valve or BOV, including improper securement, open valve, or other defect or damage, is by far the top cause of NARs from caustic railcars. Releases from the hinged and bolted manway cover, primarily due to improper securement or various gasket issues, is the second top cause of NARs from caustic railcars. Collectively, releases due to human error or equipment failures, which are considered NARs, attribute to over 80% of all caustic railcar incidents reported to DOT during 2011 to 2022. A large portion of those NARs are related to the improper securement of service equipment, which highlights the biggest opportunity for reducing preventable leaks on caustic railcars, which is the focus of this video. After this video is published, you may periodically check CI's bookstore page to find updated incident data.
It's important to remember that the party who prepares and offers a caustic tank car for transport is considered the shipper of record. This includes the unloading location that prepares a residue car for return shipment back to the supplier. It is the shipper of record's responsibility to ensure that the tank car is properly secured. If there's a leak during the movement of the car, the shipper of record will be held responsible for the incident. Following are some tips for securing caustic railcars that will ultimately lead to preventing caustic NARs. A checklist is a valuable tool to help standardize the process and to make sure steps are not omitted. The Chlorine Institute has developed checklists and various guidance that can be made available to users. CI resources will be discussed towards the end of this presentation. Be sure your procedures and checklist include the following critical tips for securing caustic tank cars. The first thing you should do before closing up a loaded tank car is to confirm the quantity of the product that has been loaded. This can be done by verifying the weight indicated on the scale, if used during the loading process, and by visual inspection through the hinged manway. Verifying the quantity will ensure that the car has not been overloaded during the loading, which will help reduce the chances of an NAR or release from the pressure relief device during shipment. Once the quantity loaded has been confirmed, inspect the hinged and bolted manway gasket and eye bolts for damage, defects, foreign matter, or any other condition that could prevent the manway from sealing properly. Ensuring that gaskets and eye bolts are clean and in good condition will help prevent releases from the hinged manway.
The following guidance on inspecting the hinged and bolted manway assumes the manway is opened during the loading and unloading process. However, loaders and unloaders that do not open the manway for their process should still conduct an external inspection of the manway gasket for abnormal conditions that have the potential of resulting in a leak during transport. Guidance addressed by the following steps is also applicable to external visual inspections. This inspection may also include a leak check, which is covered later in the video.
It's crucial that the surfaces of the hinged and bolted manway gasket are clean and free of damage, defects, and other imperfections to ensure effective sealing during transport. A presence of dirt, debris, cuts, tears, gouges, pits, scratches, or other defects can create a leak path that could potentially result in a caustic rail NAR.
Dirt and debris should be cleaned away. If other imperfections are found that could result in a leak path, it is recommended that the gasket be replaced per the tank car owner's procedures.
When the gasket is removed, inspect the sealing surface of the manway cover and the hinged manway nozzle to ensure they are clean and free from damage. If you are an unloader preparing the tank car for a return shipment to the supplier, contact your caustic supplier for guidance on replacing the manway gasket. These pictures show you what a hinged and bolted manway gasket should look like for transport, versus several examples of damaged gaskets that should be replaced before transport.
Different styles of gaskets may be acceptable based on the design of the manway and the tank car owner's procedures.
Prior to closing the hinged and bolted manway, it's crucial to inspect all of the manway eye bolts, including the safety eye bolt at the manway handle and eye bolt threads, nuts, and washers. If any one of the eye bolts or nuts are damaged, have dirty or damaged threads, or if the washers are damaged, it creates another leak path that can result in an NAR. A wire brush may be used to remove debris from the eye bolt threads for a close inspection.
Eye bolts should be free from corrosion, fatigue, cracking, stripped threads, or other wear.
Nuts should be inspected for cracking, stripped threads, or other wear. Washers should be inspected for proper size, cracks, bends, and other wear. There should not be any missing or damaged eye bolt hinge pins. It's also important to ensure that all eye bolts are the same diameter and that all nuts are the same shape, whether square or hex. The washer must sit flat on the manway cover. The images here show proper eye bolt washer fit compared to incorrect washer fit. An additional inspection should be done on the safety eye bolt, which is slightly different from the other eye bolts, to ensure it continues to function as intended. Prior to opening the manway, any internal tank pressure should be relieved through the vent valve. The design of the safety eye bolt, once loosened and still left in place on the manway cover, allows the operator to safely lift the cover slightly to verify that little or no pressure exists in the tank car, and prevent the cover from being propelled open if any significant pressure exists. This mechanism helps prevent injuries that could occur when opening a tank car that may have increased internal pressure during transport.
As shown here, there is a collar, pin, wedge, or interference-style safety eye bolt, until the cover is opened up to about 3/8 inch. They prevent the eye bolt from rotating downward, thereby allowing the tank to relieve pressure before opening the cover all the way. During inspection, it is important to ensure that the safety eye bolt is in the correct position and is not damaged to prevent securement. For collar and pin style safety eye bolts, verify the collar or pin is not missing.
For safety eye bolts designed with a wedged bottom, it is important to ensure that there is no damage and that the eye bolt is not installed backwards. The correct position for the wedge-style eye bolt is for the sloped edge of the wedge to face the manway when in the upright position.
For interference-style safety eye bolts, it is important to verify that the eye bolts do prevent the manway cover from opening all the way before fully untightening the bolts. It is important to note that caustic tank car manways may have one or two safety eye bolts based on how the tank car was originally built and the equipment owner's preferences. Regardless of the number, These inspection steps are applicable to any safety eye bolt that is installed.
Missing eye bolts, nuts, and washers should be identified and replaced. Eye bolts that are a different diameter than what is prescribed on the tank car certificate of construction should also be replaced. All nuts should be the same shape, square or hex. Those nuts not matching the others should be replaced.
These parts should also be replaced if damaged, because they could prevent effective securement.
If eye bolts or nuts need to be replaced, loaders should consult their company's tank car quality assurance program to ensure the proper procedures and personnel are used. Unloaders preparing the tank car for a return shipment to the supplier should not replace these parts themselves. Instead, unloaders should contact their caustic supplier for consultation before releasing the car for shipment. Once the hinged and bolted manway gasket and eye bolts have been inspected and verified to be in good condition, the manway can be closed. Ensure that the manway cover is in alignment with the manway nozzle and the gasket is aligned and sealed properly. Eye bolts can be placed into position without tightening to help identify alignment issues. If the manway cover does not appear to be aligned, inspect the manway hinge pin for damage and the hinged manway nozzle for roundness. A bent or damaged hinge pin or a flat out-of-round nozzle can prevent the manway from aligning and sealing properly. Sealing may also be impacted by rolling, pinching, or misalignment of the gasket. Gaskets and hinge pins should be replaced as needed, per the caustic supplier company's tank car quality assurance program. Also, contact your supplier if you identify an out-of-round nozzle before shipping the car.
Once all the hinged and bolted manway eye bolts and gasket are in good condition and in alignment, tighten all eye bolt nuts by hand until they are flush with the manway cover. Then all eye bolts should be tightened using the crisscross or star pattern torquing method using a proper tool. Sample torquing patterns are shown here for hinged manways with 6 or 8 bolts, but the concept is similar for manways and fittings with a different number of fasteners. All fasteners should be tightened so they remain secured under normal conditions through the entire duration of shipment. Caution should be taken if a pneumatic device is used to ensure it does not damage the manway cover.
Tank cars with protective housings may make tightening fasteners more difficult due to given clearances. If you have difficulty tightening fasteners, contact your supplier for recommended tightening practices. This is an important step, particularly for unloaders. After the tank car has been disconnected from the unloading process, it is important to ensure that the bottom outlet valve or BOV arrangement is properly closed and secured for shipment. There are several types of bottom outlet valve arrangements, all of which are comprised of an internal or external valve, ball or butterfly, and a cap or plug and chain assembly. Tank cars may also have an external auxiliary valve and/or a fitting with a top fittings arrangement that is engaged to operate the bottom outlet valve, referred to as a top-operated bottom outlet valve. Bottom outlet valves may also have differently designed handles, whether they be fixed, remote, detachable, and/or disengaging. Most caustic tank cars in service have bottom-operated arrangements. The pictures shown here are examples of bottom outlet valve arrangements currently used in service. Sometimes you may come across a tank car that has a top-operated bottom outlet valve arrangement, which these pictures reflect, currently used in service. In an effort to further reduce the potential for releases from bottom outlet valves, the rail industry has innovated new BOV handles. The intent of the new designs is to avoid accidental engagement and opening of the valve during transportation. These handles may be stowed separately, located completely within the skid, or disengaged from the valve when in the closed position. The pictures shown here are examples of new bottom outlet valve handles coming into service. It's recommended that you contact your supplier if you have questions when operating with these new handles. We just showed you a wide variety of bottom outlet valve arrangements you may see on a caustic tank car in your plant. But regardless of the type of bottom outlet valve arrangement installed, the primary takeaway is that it is crucial that the valve is completely closed, both the internal and external valves, the cap or plug is threaded into place, the chain is attached, and the valve handle is secured in its correct position prior to releasing for transport. It is important to ensure that the tank car's pressure relief device is closed and properly secured. Either of two types of relief devices may be installed on the tank car: a pressure relief valve or a rupture disc, as shown here. While both types of pressure relief devices are acceptable for caustic service, it is recommended that a reclosing safety relief device is used, such as a spring-loaded pressure relief valve, to help reduce the likelihood and size of an NAR. Pressure relief devices on caustic tank cars are typically rated at 165 psig, but some cars may have devices rated at 75 psig. Both ratings are acceptable. However, a higher rating of 165 psig will help reduce the likelihood of an unintentional product release from the relief device due to pressure surges in the car while in transport. If the car is equipped with a rupture disc as opposed to a pressure relief valve, careful inspection of the rupture disc assembly must be done prior to offering the tank car for transportation to ensure damage or defects are not present that could alter the intended operation of the device. In general, this can be achieved by cutting or removing the cable seal if present, removing the cap, inspecting both sides of the rupture disc, reapplying and tightening the cap, and installing a new cable seal if needed. After the cap is removed, determine if the rupture disc had blown during transit due to pressure surge within the tank car. An example of a blown rupture disc is shown here. If the rupture disc is present, look for cracks, signs of excessive wear, corrosion, missing components, and other evidence of altered condition of the device throughout the inspection process. These pictures show examples of rupture discs with altered conditions that should be addressed. A blown rupture disc, or rupture disc showing any other altered condition, should be replaced with a new disc, which can be obtained from your caustic supplier. Different style rupture disc assemblies may require different inspection and assembly steps. Note that the removal of the rupture disc is not required on tank cars that contain residue, per DOT regulations. In other words, unloaders are not required to remove the rupture disc for the visual inspection. Not removing the rupture disc and instead leaving it in place during inspection helps prevent errors in reassembly and therefore reduces the chances of an NAR. It is recommended that you refer to the DOT regulations in 49 CFR Part 173 and consult your supplier for more detailed requirements and instruction on inspecting rupture disc assemblies. After inspection, it is crucial to ensure proper assembly and securement of the rupture disc assembly. Be sure the disc is installed with proper flow direction. Original equipment manufacturers, or OEMs, provide instructions to ensure proper orientation of the disc and housing assembly. Loading facilities may also conduct a pressure leak check to ensure proper functioning of the rupture disc in addition to removing the disc for visual inspection. After all fasteners on all fittings have been properly tightened, verify that all openings to the tank car are closed and properly secured. In addition to the hinged manway, bottom outlet valve, and pressure relief device that were previously discussed, this includes closing all other operating valves and fittings after the car is disconnected from the loading or unloading system, and fastening all bolts used to secure these fittings to the tank car, regardless of whether or not they were used during the operation. All fittings on a tank car should be leak-free and tightened so they remain secured under normal conditions through the entire duration of shipment. Caution should be taken if a pneumatic device is used to ensure it does not damage any of the fasteners. Tank cars with protective housings may make tightening fasteners more difficult due to given clearances. If you have difficulty tightening fasteners, contact your supplier for recommended tightening practices. These pictures show different arrangements of fittings inside a protective housing. An operator should verify that each fitting is closed and all bolts are tool tight, regardless of whether it was used or not during the process. After all fittings have been closed and secured, it's recommended that the tank car and fittings be washed down with water to remove any spilled product. Doing so will provide evidence that the car was clean and secure prior to shipment. This is particularly beneficial when en route tampering of the car is suspected. Cleaning spillage will also help prevent corrosion of the car's steel parts. However, be aware that some older cars may have existing stains that cannot be cleaned away. While performing the washdown, it's important to reclaim the spent wash water per the applicable environmental regulations. A crucial step in the securement process, particularly for loading facilities, is to check all fittings for leaks prior to shipping a loaded tank car. For caustic tank cars, a commonly used method is the use of leak check solution to detect any leaks. This method requires the car to be under pressure, typically 25 to 30 psig, to be effective in detecting the leaks. One general tip for leak checking is to wait as long as possible after loading before doing a final leak check prior to the tank car being offered for shipment.
A long leak check dwell time may allow very small leaks to develop and become detectable.
Some shippers hold cars up to 24 hours prior to shipment and conduct a leak check as close to that time as possible before releasing the car for shipment. However, only hold the car as long as your facility's procedures state.
It is not necessary for unloading facilities to pressurize the car and conduct a leak check prior to releasing the car for the return shipment. However, it is recommended that the unloading facility still ensures that all valves are closed, fasteners are properly tightened, and the tank car is leak-free.
The first picture here shows an example of the tank car being pressurized prior to conducting a leak check. The second set of pictures show examples of leak checking different fittings using a leak check solution. There are many acceptable commercial-grade solutions on the market to use for leak checking. Here are some products currently used in the industry. After all fittings have been checked for leaks, one of the final steps to help reduce NARs is to reduce the pressure in the car as low as possible before shipping. For caustic shipments, zero pressure in the car is recommended.
Added pressure in the car increases the total shipping pressure. If too much pressure builds up in the car, the pressure relief device could potentially release during transport, or a leak can occur through an unsecured fitting.
It is less likely an NAR will occur if there is zero pressure in the car. This step is particularly critical for loaded tank cars. Safety and security go hand in hand. Before a loaded caustic tank car leaves the plant, it's recommended that tamper-evident measures be put into place to avoid tampering and other suspicious activity during shipment. Cable seals are most commonly used for this purpose. Protective housings have become a requirement for new caustic cars and are a permanent feature on the car inside of which most of the fittings are located. Older cars may have a dome-like weather cover protecting the fittings from the natural elements. Both of these protective features are recommended to be sealed with a cable seal. If a protective housing or weather cover are not present, it's recommended that all the fittings be individually locked with cable seals. It's also recommended that the hinged and bolted manway cover be secured with a cable seal. The pictures shown here provide examples of the different ways cable seals are used on caustic tank cars. Different materials of cable seals are acceptable. Steel or plastic are most commonly used. Due to the reduced risk of tampering and leaking of a residue tank car, it's not necessary for unloaders to use cable seals for the return shipment unless requested by their supplier. Before offering the tank car for shipment, it's also recommended to take pictures of secured fittings and tamper-evident measures. These pictures provide confirmation of proper securement before shipment, which is particularly helpful when fittings are found to be loose during transit due to tampering rather than improper securement. Shippers can avoid violations and fines if they can provide this evidence. We just went through numerous steps and equipment that should be taken into account when ensuring a caustic tank car is properly secured and prepared for transportation. We also highlighted when an unloader may not need to perform the same steps a loader would. Before we wrap up, let's briefly review the steps we discussed. starting with important steps for a tank car loader to perform prior to releasing a tank car for shipment. First, you want to confirm the weight of caustic loaded in the tank car to ensure it's not overloaded. Overloaded tank cars have a higher chance of causing NARs. Second, it's important to inspect the condition and fit of the hinged and bolted manway gasket and eye bolts, including nuts and washers, regardless of whether or not the manway was open during the process.
Upon inspection of the hinged manway gasket and eye bolts, you want to make sure to properly tighten all eye bolts.
Before releasing the tank car, you want to ensure that the bottom outlet valve, including the cap or plug, and various handles and fittings, are closed and properly secured. Next, it's crucial to ensure that the pressure relief device, a reclosing pressure relief valve or non-reclosing rupture disc assembly, is in working condition and properly secured. If a rupture disc is installed, you are required to perform a full visual inspection of the rupture disc and its housing, including removal of the rupture disc. Once the hinged manway, bottom outlet valve, and pressure relief device are all secured, it's important to verify that all other valves and fittings are closed and properly secured, even if they were not used during the process. After all fittings are secured, it is beneficial to wash any residual product off of the tank car. Doing this helps provide evidence that the car was clean and secured when it left the facility. Prior to releasing the car for transport, it's important to check for leaks using a leak check solution to ensure all fittings are properly secured. To reduce the risk of an NAR occurring during transport, it is recommended to reduce the internal tank car pressure to 0. Finally, installing cable seals on all applicable fittings and housings will help deter unauthorized persons from accessing the tank car service equipment and reduce the chance of them causing an NAR. Now let's briefly review the steps that are important for a tank car unloader to perform prior to releasing a tank car for shipment. Many of the steps are the same for loaders and unloaders, which we just reviewed. But let's quickly highlight those steps that are either different or not required for unloaders to perform. First, it is not necessary for an unloader to confirm the weight of the product in the tank car, since it will most likely be fully unloaded to the extent possible. Tank cars having residual amounts of product are less likely to cause an NAR. When it comes to the pressure relief device, it is still important for the unloader to ensure that the device is in working condition and properly secured. However, if a rupture disc is installed, the unloader is not required to remove the rupture disc for a full visual inspection. It's only necessary for the unloader to remove the rupture disc housing cap to conduct the visual inspection. Depending on the facility's particular process for unloading, it may not be feasible for the unloader to add pressure to the tank car in order to conduct a leak check on all fittings. However, if the unloader has the ability to perform a leak check, it is recommended to do so. Regardless of whether a leak check is performed or not, it's still important for the unloader to ensure that all valves and fittings are closed and properly secured. Finally, while not common, unloaders may be requested by their caustic supplier to secure fittings with cable seals for the return shipment. One final and very important comment. If for some reason the tank car cannot be sealed properly and leaks continue to be detected, it is critical that you do not ship the car. Tank cars having active leaks are prohibited from transport by DOT regulation until the leak has ceased. If transport is required to repair an issue causing a leak, a one-time movement approval must be obtained by the caustic supplier from DOT to allow movement to a tank car repair facility. If you are offering a return shipment, mark the location of the leak and contact your supplier immediately. Your caustic supplier will work with you to address the leak and properly prepare the car for return shipment. The Chlorine Institute offers a variety of pamphlets and other information that addresses the safe handling of caustic. Pamphlet 87, Recommended practices for handling sodium hydroxide solution and potassium hydroxide solution, caustic, tank cars, provides general guidance on handling caustic tank cars, including loading and unloading steps. Pamphlet 87 also includes a sample checklist that may be used for preparing a tank for shipment. This pamphlet also references relevant U.S. and Canadian hazardous materials transportation regulations.
Most Chlorine Institute publications are free and available for download from the Chlorine Institute's website. As mentioned earlier in the presentation, additional NAR guidance may be found on the AAR's NAR website.